Good morning. In today's lecture, we are going to discuss applications of sine, cosine and projection rules. Exercise 3.2, sum number 6. In triangle ABC, prove that a cube sine of b minus c plus b cube sine of c minus a plus c cube sine of a minus b equal to 0. Let me explain. See, there are three terms on left hand side. Second and third can be obtained by making cyclic changes in the first. What do you mean by cyclic changes? Replace a by b, b by c and c by a, both small and capital, right? So in such cases, it is sufficient to simplify any one part, preferably the first one. Remaining two can be obtained by making cyclic changes. See, by sine rule, what is a upon sine a equal to b upon sine b equal to c upon sine c? It is k. So a is k sine a, b is k sine b, c is k sine c. Let me explain. Now, consider a cube sine of b minus c. I write a cube as a square into a, right? I replace only this a by what? K sine a. See, I have written all the steps. Now, a plus b plus c is pi because these are angles of a triangle, right? So what is a? Pi minus b plus c. Here bar is treated as bracket. Now what is sine of 180 minus theta? Sine theta. So this is nothing but sine of b plus c into sine of b minus c. Note that de facto formula is for 2 sine a sine b. That is why I have written a square k upon 2 into 2. Now 2 sine a sine b is cos of a minus b. That is this angle minus this angle. So 2c minus sine of, I'm sorry, 2 sine a sine b is cos of a minus b minus cos of a plus b. This angle plus this angle, which is cos 2b. Okay. So apply to sine a sine b formula. What is cos 2 theta? 1 minus 2 sine square theta. Use that. Open the brackets. 2 sine square b minus 2 sine square c. Take 2 common. Cancel that with this 2. To get a square k into sine square b minus sine square c. But from 1, sine square b is what? B square by k square. And what is sine square c? C square by k square from 1. Now take 1 upon k square outside the bracket. So what remains is a square upon k. That is 1 upon k a square into b square minus c. Observe this. If it is a cube into sine of b minus c, RHS is 1 upon k a square into b square minus c square. Make cyclic changes on both the sides to get second and third results. Add them to get the required answer. Yes, I'll explain this part once again. By making cyclic changes, we get these two results. What do you mean by cyclic changes? Replace small a by small b by small c, and small c by small a. Same for capital ABC. Now add 2, 3 and 4. Please do not write in this fashion. You have to actually write these terms. Now on right hand side, take 1 upon k common to get in bracket a square into b square minus c square plus b square into c square minus a square plus c square into a square minus b square. Open all the brackets. You will notice that you get 1 upon k into 0. Now k is not equal to 0. So 0 upon non-zero equal to 0. That's it. Let me explain first. You have to write the solution after the lecture. This is an important sum. Exercise 3.2, seventh one. In triangle ABC, if cot A, cot B, cot C are in arithmetic progression, then show that A square, B square, C square are also in arithmetic progression. See the solution. By sine rule, sin A upon A is sin B upon B, sin C upon C is K. Now some students say, sir, sine rule is A upon sin A equal to. Yeah, I agree. But I haven't written this as 2R. In fact, I can write sin A upon A equal to sin B upon B equal to sin C upon C equal to 1 upon 2 capital R. But that is a constant. Let it be K. Is that clear? and therefore sin A can be replaced by AK, sin B by BK, and sin C by CK. Now what is given? Cot A, cot B, cot C are in AP. What do you mean by arithmetic progression? Difference between two consecutive terms is constant. So cot C minus cot B is cot B minus cot A. That is cot A plus cot C equal to 2 cot B. Right? What is cot A? Cos A by sin A. What is cot C? Cos C by sin C. RHS as it is. Here LCM is sin A sin C. Numerator becomes sin C cos A plus sin A cos C, which is expansion of what? Sin of A plus C. Now A plus B plus C is pi. So what is A plus C? Pi minus B. See, reason is given. Now sine of 180 minus theta is what? Sine theta. On the right hand side, cot is written as cos by sine. Okay. So I get sine B upon sine A sine C is 2 cos B upon sine B. That is sine square B upon sine A sine C is 2 cos B. Now we have already written sine B is KB. So this is K square B square upon KA KC. On the right hand side, cosine rule is used. Cos B equal to A square plus C square minus B square upon 2AC. Rearrange the terms, simplify to get what? 2B square equal to A square plus C square. This happens only when A square, B square, C square are in arithmetic progression. Sum number 8, this is an important sum. In triangle ABC, if A cos A is B cos B, then prove that the triangle is either a right angle or an isosceles triangle. We begin with A cos A equal to B cos B. By sine rule, A is K sin A, B is K sin B. Divide by K and then multiply by 2. So 2 sin A cos A is 2 sin B cos B. So sin 2A is sin 2B. Some students say that therefore 2A equal to 2B, A equal to B. So triangle is isosceles. But this proves only one part. We have to prove that triangle is right angled also. So actually at this stage only we can say there are two possibilities, 2A equal to 2B or 2A is what? 2A is nothing but pi minus 2B. Reason? Sine of 180 minus theta is sine theta, right? But I have used different method. I have brought this term to LHS. Now it is sine A minus sine B formula. Sine A minus sine B. 2 cos of 2A plus 2B upon 2, that is A plus B, into sine of first angle minus second angle upon 2, that is sine of A minus B, right? Now product of two terms is 0, so either first is 0 or second is 0. Now first equal to 0 gives cos of A plus B is 0, but cos pi by 2 is 0, that is A plus B is pi by 2. So what must be the third angle? Pi by 2 only. This gives me that triangle is right angle. And what about second part? Sine of A minus B equal to 0, but sine 0 is 0. So A minus B must be equal to 0. So A must be equal to B. That is, triangle is isosceles. So from these two we can say that if A cos A is B cos B, triangle is either right angle or an isosceles triangle. Sum number 9, with the usual notations, prove that 2 in bracket BC cos A plus AC cos B plus AB cos C is A square plus B square plus C square. We begin with LHS. Open the brackets. Now use cosine rule. It is better if you write the reason here, cosine rule. So by cosine rule, what is cos A? It is B square plus C square minus A square upon 2BC. This is cos B and this is cos C. Here 2BC, here 2AC and here 2AB get cancelled. then write remaining terms, you will notice that you get a square plus b square plus c square, which is nothing but right hand side. Now we are going to discuss applications of sine, cosine and projection rules. These are the applications: half angle formula for area of a triangle, Heron's formula, and then Napier's analogy. First, you just read this and then I will explain. Now we discuss this. In any triangle ABC, if 2S is A plus B plus C. What is A plus B plus C? Sum of the lengths of three sides of a triangle, that is perimeter. So perimeter is denoted by 2S. So S represents semi-perimeter of triangle. We have to prove that sine of angle A by 2 is root of S minus B into S minus C upon BC. Just remember this, because these two can be obtained by making cyclic changes. Or you may also remember this as it is sine of A by 2. So under radical sign, B and C will be there. A won't be there. Now proof is very simple. We begin with cos A. What is formula for cos 2 theta? 1 minus 2 sine square theta. So cos A is 1 minus 2 sine square A by 2. So what is 2 sine square A by 2? 1 minus cos A. Now by cosine rule, what is cos A? B square plus C square minus A square upon 2BC. Now LCM twice BC. So numerator is 2BC minus B square minus C square plus A square. Rearrange the terms to get sorry, A square minus in bracket B square plus C square minus 2BC. This is perfect square of B minus C. What are the factors of square of the first minus square of the second? First plus second into first minus second. Now I will just rearrange the terms. This is what A plus B minus C. Now I want that 2S should be involved. What is 2S? A plus B plus C. And therefore see, I write A plus B minus C as what? A plus B plus C minus 2C. Simple. And here A plus B plus C minus 2B. See in the next step. Yes, A plus B plus C minus 2C, A plus B plus C minus 2B. Why? Because we want to involve 2S in the answer. Now this can be replaced by 2S. So 2S minus 2C is 2S minus 2B. Take 2 common from both the brackets. So sine square A by 2 becomes, this 2 gets cancelled, twice S minus B S minus C upon BC. But that is twice, because LHS is twice sine square A by 2, C, twice. So effectively, what is sine square A by 2? S minus B into S minus C upon BC. Take roots on both the sides. Initially, we will say plus minus, but A happens to be the angle of a triangle. So it lies between 0 and 180 degree. So A by 2 has to lie between 0 and 90 degree. Means first quadrant. So sine ratio is positive. So finally, sine A by 2 is plus root of S minus B into S minus C upon BC. By making cyclic changes, what will be sine B by 2? Root of S minus C into S minus A upon CA, and sine C by 2 is root of S minus A into S minus B upon AB. Next result, in any triangle ABC, if 2S is A plus B plus C, then cos A by 2 is root of S into S minus A upon BC and so on. We prove the first part only. What is cos A? 2 cos square A by 2 minus 1. So what is 2 cos square A by 2? 1 plus cos A. By cosine rule, cos A is B square plus C square minus A square upon 2BC. LCM 2BC, this is numerator. Now first three terms, you will notice that it is square of B plus C minus A square as it is. What are the factors of P square minus Q square? P plus Q, P minus Q. So it is B plus C plus A into B plus C minus A. That is A plus B plus C. Now we want that 2S should be involved. And what is 2S? Perimeter. A plus B plus C. So observe this. Though it is B plus C, minus a. I write this as a plus b plus c. So minus 2a. I have written the same in different form, which is allowed. So that a plus b plus c can now be replaced by 2s. So 2s into 2s minus 2a. Okay. So take 2 common and so on. So 2 cos square a by 2 is this. So it is cos square a by 2. S into s minus a upon bc. Now you may think what happens to this 2. See, LHS is 2 cos square a by 2. See, 2 cos square a by 2. So this 2 gets cancelled with that 2. To get cos square a by 2 equal to s minus a by bc. So what is cos a by 2? It is plus minus root of s into s minus a upon bc. Now A is an angle of a triangle. So A lies between 0 and 180. So A by 2 has to lie between 0 and 90 degrees. That is first quadrant. So cosine ratio is positive. So what is cos A by 2? Root of S into S minus A upon BC. Similarly, by making cyclic changes or using analogy, what is cos B by 2? Root of S into S minus B by AC, and cos C by 2, root of S into S minus C upon AB. As we have obtained for sine and cos, we can write for tan also. In any triangle ABC, if 2s is a plus b plus c, then what is tan a by 2? Root of s minus b into s minus c upon s into s minus a and so on. I don't think this will be asked in exam, but if asked, you can directly use these results. That we know that sine a by 2 is this is cos a by 2. What is tan a by 2? Sine a by 2 upon cos a by 2. Simplify to get tan a by 2 as root of s minus b into s minus c upon s into s minus a. Similarly, we can write for tan b by 2 and tan c by 2. Now, formulae for area of a triangle. The area of triangle ABC is given by, it is usually denoted by delta equal to half BC sin A. Make cyclic changes to get half CA sin B, same as half AB sin C. Consider this diagram. Here A is an acute angle, here it is an obtuse angle. Take origin at A, x-axis along line AB and y-axis perpendicular to line AB. Draw segment CM perpendicular. This is actually height of the triangle, because what is formula for area of triangle? It is half base into height. Now, what are the coordinates of B? C0. And what are the coordinates of C? See, coordinates of any point are x equal to r cos theta and y equal to r sin theta. R is the distance of that point from origin. So distance of C from origin A is AC, which is small b. Theta means this angle A. And that is why coordinates of C are B cos A and B sin A. Now, sine ratio of angle of a triangle is always positive, whether it is an acute, right, or obtuse. So what is CM? It is nothing but mod of B sin A, but sin A is positive, so just B sin A. So area of triangle is half base into height, that is half ABCM, that is half CB sin A, that is half BC sin A. Now by sine rule, A upon sin A is B upon sin B, C upon sin C. So B sin A can be replaced by A sin B and C sin A can be replaced by A sin C. So area of triangle becomes delta equal to half BC sin A, same as half CA sin B, same as half AB sin C. The next result is again an important one suggested by Heron's formula. If ABC are the lengths of the sides BC, AC and AB of triangle ABC and A plus B plus C is 2S, then the area of triangle ABC is given by delta equal to root of S minus A, S minus B, S minus C. Proof is simple. We have already proved these results, that sine A by 2 is root of S minus B, S minus C by BC. Cos A by 2 is root of S minus A by BC. Now what is area of triangle? It is delta equal to half BC sin A. Now sin 2 theta is 2 sin theta cos theta. So sin A is 2 sin A by 2 cos A by 2. Substitute for this. Simplify to get area of triangle as root of s into s minus a into s minus b into s minus c. Exercise 3.2, sum number 10. In triangle ABC, if A is 18, B is 24 and C is 30, then find the values of cos A, sin A by 2, cos A by 2, tan A by 2, area of triangle ABC and sin A. Now we will use formulae. What is given? Small ABC are given. So find out 2s, that is perimeter. It is 72. So what is S? Semi-perimeter 36. Now what is cos A by cosine rule? B square plus C square minus A square upon 2BC. You will have to tell me the answer. Substitute the values. Similarly, what is sin A by 2? Root of S minus B into S minus A upon BC and so on. Right down. So cos A comes out to be 4 by 5 and sin A by 2 comes out to be 1 upon root 10. Cos A by 2, you may say, sir, sin square A by 2 plus cos square A by 2 is 1. So cos square A by 2 is 1 minus. Yes, that is correct. But here we will use formula only to get 3 by root 10. Now it is tan A by 2, sin A by 2 by cos A by 2. We have obtained both sin and cos. So take the ratio to get 1 by 3. Next part is area of triangle ABC. Use Heron's formula. Substitute the values to get root of 36 into 18 into 12 into 6. Now 12 is what? 4 into 3. So this is 36 into 18 into 4 and 3 into 6 is again 18. So what is the root? Root of 36, 6. Root of 18 square, 18. Root 4 is 2. So the area comes out to be 216 square unit. The last part is sin A. Sin A is asked. Now what is area of triangle ABC? It is half BC sin A. But area is found to be 216. So 216 into 2 upon BC will be sin A. But B is 24. And what is C? 30 to get 3 by 5. Another method is, just a minute. We have already obtained cos A. Cos A is 4 by 5. So from this also we can find sin A as 3 by 5. Right. Now this is sum number 11. In triangle ABC, prove that B plus C minus A tan A by 2 is C plus A minus B tan B by 2 is A plus B minus C tan C by 2. You will notice that we will simplify first part and then by making cyclic changes, only left hand side will change, right hand side will remain the same. See, begin with B plus C minus A tan A by 2. Now what is B plus C minus A? It is A plus B plus C minus 2A, simple. Into what is tan A by 2? Root of S minus B S minus C upon S into S minus A. Now A plus B plus C is perimeter, twice S. So twice S minus twice A into this. Take 2 common to get S minus A, right? See, this is S minus A outside the radical sign and here S minus A in the denominator but under radical sign. So this can be simplified as twice root S minus A, S minus B, S minus C upon S. Now you will notice that if cyclic changes are made here, this will change to C plus A minus B tan B by 2, second term. Will right hand side change? No, it will be 2 into root of S minus B into S minus C into S minus A, same as this, divided by S. Again make cyclic changes to get this, same as this. See, in fact, here they have again proved that these sides are equal. Actually it is not required, because you can just say that by making cyclic changes, only left hand side changes, right hand side remains the same, so they are equal. So this part is actually not required, but you have to say from 1, 2 and 3 right hand sides are equal, so left hand sides must be the same. Sum number 12. In triangle ABC, prove that sin A by 2 into sin B by 2 into sin C by 2 is square of the area of triangle upon ABCS. We begin with LHS. Put for sin A by 2, sin B by 2 and sin C by 2. You will notice that it is just S minus A, S minus B, S minus C upon ABC. Now, in the formula for area of triangle, that is in Heron's formula, it is root of s minus a, s minus b, s minus c. So first we multiply numerator and denominator by s. Anyway, we are going to require s in the denominator. So this is now s minus a, s minus b, s minus c, which is square of root s minus a, s minus b, s minus c. Denominator abcs as it is. Now this is the formula for area of triangle, Heron's formula. So this becomes square of the area of triangle ABC upon ABCS, which is nothing but right hand side. This is actually not in the textbook, but try this sum. Angles of a triangle are in AP and B is to C is root 3 is to root 2. Find angles of that triangle. This is not given in the textbook, but try this. We'll discuss solution in the next lecture. Angles of a triangle are in arithmetic progression. B is to C is given to be root 3 is to root 2. Find angles of the triangle. So this sum, and you have to prove cosine rule using sine rule. So that is another sum for homework. So that's it for today.